So today we're going to talk about something that might just flip the script on how we build AI. It's a new model called 𝗵𝗃𝑟1, but honestly, it's more than just a model. It's a whole new playbook for how to teach a machine to actually reason. Let's dive right in.
It all really boils down to this one massive question. For years, the approach has been to teach AI to mimic human thought, to, look and sound like it's reasoning. But is that the same thing as actually thinking? Well, 𝗵𝗃𝑟1 comes along and suggests there's a much better and, frankly, way more powerful way to do it.
Okay, so to really get why this is such a huge deal, we first need to look at why the old methods were kind of hitting a wall. We were basically trying to teach reasoning by showing an AI what reasoning looks like. And it turns out that comes with some really serious limitations.
Right, so on the left, you've got the old way. We'd feed these models tons and tons of examples of human reasoning, these step-by-step chain-of-thought explanations. And we'd basically tell the model, hey, go do this. And the model got really good at mimicking the style of reasoning. But now look at the right. This is the new idea. Instead of showing it how to reason, you just give it a goal, and you reward it when it gets the right answer. The model itself has to figure out that the best way to get that reward consistently is to develop a genuine reasoning process all on its own.
And this gets us to the absolute heart of the breakthrough with 𝗵𝗃𝑟1. It's this fundamental shift from supervising the process to just rewarding the outcome. It's kind of like being less of a tutor, meticulously checking every step of the homework, and more like a coach who only cares about the final score on the scoreboard.
What's so cool here is how elegantly simple this pipeline is. A problem goes in, the model spits out some reasoning and a final answer. Then, and this is the most important part, an automatic verifier just checks if that final answer is right or wrong. It doesn't care how the model got there at all. If the answer's correct, boom, the model gets a reward. Just a simple number, like a +1. If it's wrong, it gets nothing. You do this millions and millions of times, and the model starts to learn that the most reliable path to that +1 is to develop its own internal logic.
And this, right here, this is the paradigm shift. We're not trying to solve a language problem anymore. We're not teaching the AI how to write beautiful, human-sounding explanations. No, we're solving a control problem. We are building a system that is just relentlessly, single-mindedly optimized for one thing, getting the right answer. Reasoning isn't the goal we teach, it's the strategy the model discovers on its own to win the game.
Okay, so this approach is obviously incredibly powerful. But, and you knew there was a but coming, it is not a magic bullet. This method of incentivizing reasoning creates its own very specific set of rules and, more importantly, its own limitations. Let's dig into those.
This table just lays it out so clearly. Look at where this technique absolutely shines. Math, competitive coding, logic problems. Why? Because in these areas, there is a single, verifiable, black and white correct answer. The reward signal is perfect. But then, what about creative writing? Or subjective reasoning, like arguing about art or philosophy? There's no automatic verifier, no truth oracle that can give a simple thumbs up or thumbs down. And in those areas, this method just completely falls flat.
And this right here is the fundamental weakness, the Achilles heel we have to understand. The entire system is built on having a perfect judge, an oracle that can definitively say correct or incorrect. If you can't build that verifier, you can't use this method. It's like having this incredibly powerful engine that only runs on one very specific, very rare type of fuel.
Now let's get just a little technical for a second because this is a really critical distinction. The specific tech they used here, it's called GRPO, and it's brilliant at solving an optimization problem. It makes the training process super stable even for really long, complex chains of reasoning. But here's what it doesn't solve: the alignment problem. It makes the AI incredibly good at hitting the goal you set for it, but it gives you zero guarantees that you've actually set the right goal in the first place.
And that brings us to the future. Because in solving this huge problem of how to create reasoning from scratch, 𝗵𝗃𝑟1 has accidentally stumbled upon and exposed an even bigger challenge for the entire field of AI.
This quote, straight from the paper, says it all perfectly. The quality of the reasoning behavior is bounded by the quality of the reward signal. In other words, the AI's thinking can never be better than our ability to grade it. If our grading system, our reward signal, is flawed, the reasoning it produces will be flawed too. It's like a perfect student with a bad textbook. It'll learn all the wrong lessons with perfect accuracy.
So what happens when that reward signal isn't quite perfect? Well, you get this whole new host of problems. The model might find some clever loophole in your verifier. We call that reward hacking. Or it might produce these monstrously long, unreadable chains of logic just because the system never told it not to. It can even become biased against creative solutions if the verifier only knows one textbook way to solve a problem. The system does exactly what you tell it to do, which, it turns out, is almost never what you actually want it to do. And that's the bottom line. The big takeaway is this: we've gotten really, really good at building the engine. The new bottleneck is designing the steering wheel and drawing the map. The challenge is no longer, how do we make the model smarter? The challenge is now, how do we even define smarter for all the complex, messy tasks that don't have a simple right or wrong answer? The problem has shifted from building better models to defining better goals.
This slide just visualizes that massive leap in complexity perfectly. On the left, that's the world DeepSeek R1 has pretty much conquered. Reward is just a simple function of the final answer. It's clean, it's mathematical. But on the right, that's the future. That's the messy reality. How do you write a mathematical function for a reward that has to balance correctness with safety, robustness, uncertainty, and a dozen other fuzzy human values? That is the grand, unsolved challenge the entire field is staring at right now.
So what are the big takeaways from all this? Well, DeepSeek R1 has given us hard scientific proof of a few really important things. Number one, real reasoning can emerge on its own, without just copying human examples. Two, this outcome-based incentive model is flat out better than just imitation. And three, these reasoning strategies the big models discover can actually be transferred down to smaller, more efficient models. Which leaves us with this final, crucial thought. We are building systems that are getting unbelievably good at hitting any target we set. They will find the most efficient, most optimized path to whatever goal we point them at. So the question is no longer just a technical one, it's a deeply human one. As this technology gets more and more powerful, who gets to decide what the right target is? That's the real conversation that DeepSeek R1 has forced us all to start having.